We're going to start logarithmic functions. Logarithms are totally brand new for most of you. I don't think you've seen them in your life before. And we're doing section 8.4. Let's get started. All right, we're going to talk about inverses. We've talked about this before. What's the inverse of addition?
Subtraction.
Subtraction. What's the inverse of multiplication? Division. Good. And the inverse of squared? Square root. If I said cubed, it would be cube root. So today we're going to talk about the inverse of exponential functions. You've been graphing all those exponentials until today. We're going to do the inverse of those. And that inverse is called logarithms. All right. So the inverse of exponentials is logarithms. This is brand new for you. You might have actually, the only thing you might have seen them is on our Formula Madness. Okay. So here's the rule. You've learned this. If we have log, this is at some base, y equals x. How did I translate this for your Formula Madness? Y equals what? B to the x. And so I remember it, for the base comes over to the x equals y. I always go the inside to the outside equals y. So I always take it as b to the x equals y. I always go in and out and around. B to the x equals y. You've already memorized that. Now we're going to use it. Okay. All right. So if log base 2, 32 is 5, how do I translate that? What to the what equals what?
2 to the 5 equals 32.
2 to the 5 equals 32. There we go. Okay. If we have log base 3, 81 equals 4, then what does that mean? 3 to the 4th equals 81. Okay. So we just take the base to the outside equals the inside. Questions? Okay. You memorizing this before we got to it made this easy. Okay. You didn't know why you were memorizing this, whether it was 4, it didn't matter, but now you have a y to put with it. So sometimes blindly memorizing something is not a problem. It's actually going to make your life easier later. Okay.
That's why I memorize scripture.
All right, so let's do some. Exactly. That's why we do scripture all the time. We never know when we're going to use it. All right, so this is what I want you to do. I want you to get out number 1 in your homework. Log base 4, 16 equals 2. It says to rewrite it in exponential form. This is in logarithmic form. So what to the what equals what on number
4 to the 2.
4 to the 2 equals
16.
16, and you are finished. That's the answer for number 1.
The whole 5 of these.
Do number 3. Let's check it. I'm going to let you do it by yourself. Check number 3. Just give me some kind of indication that you're done. A pencil up, pencil down, something. Okay, I've got some people who are done. I've got 17 to the what power?
2.
2 equals
289.
289. You don't need to check it. You don't need to do anything with your calculator. You just need to write 17 to the 2 equals 289. Now we're going to go backwards. I think these are harder. We're going to put them now in logarithmic. So when we had this one up here, 4 to the 2 equaled 16, right? Mm-hmm. And so the 4 was, I always call it at the base of 4. What one is the base over here?
2. 7.
7. And it actually, when we name this,
right.
This is called the base and the exponent. 7 is called the base even when we're naming it. So this is log base 7. Log, base 7. The 2 is the exponent which goes outside, and 49 goes here. So we can check it by saying 7 to the 2 equals 49, and that is true. Okay?
What do we do with a fraction?
Good question. All right, let's do that one. We don't do anything different. We just write it as is. What is the log? What's the base of that log?
8.
8. And what goes on the next to the 8, or the log 8, I mean?
1 over 64.
1 over 64 equals...
No, 2. Negative 2.
Very good.
No.
Don't let that fraction scare you.
No, I
Notice that the fraction, the negative actually means that we're going to turn it into the reciprocal, right? So there's a true statement here. Well, we're going to do some logarithms on our calculators. I want you to get your calculator out. This is as easy as just typing them in. But we need to first find your log button. right there. It has a big log right there. Okay? Capital. This one is called the common log. This is automatically log base 10. Your calculator has no other bases except log base 10. That's why you have a change of base formula, so you can change the base to any other log so your calculator can do it. Okay? But your calculator only does log base 10. That's not entirely true. The log button will only do log base 10. There is one other button, and that was the common log, by the way. There's one other button that's called the ln, and I don't know why, but they always do it as a lowercase. When I write ln,
Mine says all of both are uppercase.
yours are uppercase. Normally on your homework or any other time, they're going to write it, they're going to do an ln, and I always write my ln like, oops. You can do a cursive, but I always do ln. A cursive L, that doesn't look like a 1 or something strange. I always do a cursive when I write mine. I'll show you where it is on the calculator. It's right below the log. Okay? You've been using it all along for the E that you've been putting into your graphing. E is the inverse of ln, just like 10 is the inverse of log 10, or 10 to the x. So this is called the natural log. This is called natural log. ln is the same as log base e, if you want to write that down somewhere on some little note sheet. So you understand that ln is log base e. Most of my life, I didn't understand why ln was natural log until I started thinking more grammatically. And the French were the ones who came up with this, I believe. It's a French term. And if you know anything about Latin and French and Spanish, the adjectives come after the nouns. Natural log, which one's an adjective and which one's a noun?
And the adjective is natural. And the noun is
The adjective is natural and log is the noun. In Spanish, if you're going to say a white house, you don't say Blanca casa, you say Casa Blanca. They put their adjectives after. So we have ln for natural log. Okay, so that's why we have an ln. It's backwards. So if anybody who is interested in knowing that, you now know. All right. Now here we go. Your homework's 11, 12, 15, and 16. We're going to do these. You're going to first just type in your calculator log. Some of you have a parentheses after that. And a 32. You're going to type in the log button and 32 and hit enter. And they want you to give it to the thousandth. That is 3 decimals.
What?
Log. Push your log button and 32 and hit enter.
Oh.
There you go.
My bad. That's what you meant. I was like, what else?
What did we get for log 32?
I got 1.505.
505. Please confirm that.
That's what I got.
Okay. These problems are very straightforward. You just have to type them into your calculator. Do log 30.
It's 1.477.
We confirmed that it was 474. Okay.
477.
477. Thank you. All right. ln. Now you're going to, number 15, notice you're going to use your ln button now and not the log button. You're going to use your ln button in 58. You just do it the same way. Type in ln and 58. What did we get?
4.060.
So we got everybody else got that too? Okay, good. What about 16?
1.107 is what I got.
All right, fantastic.
Because I'm blind.
Just our calculator exercise right now, getting used to using your calculator with this. All right, now we're going to find the inverse function. The inverse function is going to work the same as we were doing before. I want you to just watch this first. Unless you absolutely want to write this down. All right, if I said y equals log base 3x, I want us to find the inverse. So what I did is I just turned it round also beforehand because I like my y to be over here so that my outside to the that thing works. So I'm going to change my x's and y's. When we were finding the inverse in the past, we switched some things around. What did we switch around? First, we changed the y to f of x to a y, but then we switched something. The x's and the y's. So we're going to switch the x's and the y's. Here we go. Now, my job now is to solve for y, correct? since we have logs and we have that rule, we have the base to the outside equals the inside. So 3 to the what equals what? 3 to the x. It's the rule we talked about before. 3 to the x equals y. We have solved for y. We didn't start out with an f of x, so you don't have to put that f to the negative 1 or the inverse thing. We can just be done. This is the inverse function of this one. Are you with me so far? Yeah. All right, here's another one to watch. We're going to just watch. We have an ln this time. We had an ln before. We're going to find the inverse. I always like my y to be on the other side. Doesn't really matter because I just like my base, my y's to be on that side. All right, we're going to switch the x and the y. So I've put an x in the y place and a y in the x place. What is ln? Ln is base what? E. All right, so this is another way of saying log e. So there's a little invisible e right there. So it's e to the what equals what?
To the n equals L?
No, e to what?
To the
e to the inside, the base to the outside equals the inside, correct? So it's e to the x equals y plus 1, okay? The rule we had before was log base e, and so that was e to the x equals y plus 1. Am I finished? I'm solving for what?
Y.
Y.
So
move the 1 over. How am I going to move the 1 over?
Just subtract.
Just subtract it over, correct? So I'm going to have y is going to equal e to the x minus 1. All right? We've watched these two, so let's do some now. Let's do number 23, 25, 27, and 29. You don't have to, but I've been wanting to have my y on the other side. I just like my y on the other side. You can do it however you want, but I like my y on the other side. This is number 23. What base is this one? If there's no base at the bottom, what is it naturally?
10.
10. So this is 10 to the... Oh, we have to switch the x's and the y's, don't we? So I'm going to have log y plus 4 equals x. So you with me so far?
Yeah.
That's an invisible 10 down there. 10 to the what equals what? 10 to the
X.
It's the base to the outside equals the inside.
So log to the x equals 10?
10 to the
10 to the x equals y plus 4.
Yes, 10 to the x equals y plus 4. What do I do now?
10 to the x.
I moved the 4 over.
Move the 4 over, so I'm going to subtract it over, correct? So my inverse will be y will equal 10 to the x minus 4. Let's do number 25. I like putting my y on the other side. And before I can start switching things around, I need to get that ln x all by itself. I need that negative 8 gone.
Okay, so it's not an 81n? Really
That is not an 81n. Very good. That's another reason why I like to have
That is what it
cursives.
looks like.
It does look like an
Line here is
81n.
gonna
So,
be in trouble
so when
this week.
you know you're doing logarithms, that's got to be an L and N. So it's got to be ln. Okay. All right. So I got to get that negative 8 out of there. How am I going to do that?
Add it over the other side.
How much?
Add it.
I heard add it, not add it. Divide it. I'm going to divide the negative 8. It's not an 81. So I will now have ln x.
Wait, L and Y.
We will be switching that in a minute. I just haven't gotten there yet. Yes. We can switch the x and the y now. ln y equals x over negative 8, or negative x over 8, however you want to do it.
You may multiply both sides by negative 8?
No, how do I get that? This is a log base what? What's
E.
a e? It's e to the what equals what?
E to the x over or negative 8.
Mm-hmm. Equals y. Yes. There's an invisible e right there. So it's base to the outside equals the inside. So it'll be e to the negative x over 8 equals y. We have now solved for y. Now this one, the 27 and 29 don't have logs at all. But the inverse of an exponent is a log, so you will end up with a log. We're going to switch the x and the y. I will have x equals 10 to the y over 2. Oh, terrible colors. X equals 10 to the y over 2. I'm solving for y. I need to get the 2 out of there. What am I going to do? Multiply. So I'll have 2x equals 10 to the y.
Wouldn't it be x squared?
Since I'm dividing by the 2, to get it over there, I will be multiplying. And 2 times x is 2x. Okay? All right. We know that if you had log,
So
which is
the
based,
answer?
not yet. I have to solve for y, and y is not done. Remember, if I have this, it means 10 to the x equals y, correct?
Yeah.
All right. So how do I get this into this form? So how do I write it?
Log base 10y equals 2x. Log base 10 times y equals 2x.
Log base 10, which we don't really have to write the 10. What goes next?
Y. 2x.
Is it 2x or is it y?
I think it's 2x in the place of y up there.
It is the 2x, and it equals y. This exponent is the outside. Wait a second.
Wait. Yeah, that's what I did.
All right, let's do another one. Let's do number 29. We got to move. We can switch the x and the y first, or we can move that -3, that negative and that 3 first. It doesn't matter. Which do you want to do first?
Switch x and y.
Switch the x and y. Okay. So we're going to go x. I like to put the x on the other side. Negative e to the y over 3 equals x.
Why do you put the x on the other side?
Because it was still in the same form we had up there when we had log. If I go a, b, then it's 10 to the b equals a.
I like that better. That's like a formula we can look to rather than
Yes.
confuse it.
Yeah, because it's these x's and y's over here. Because notice how there's a single thing with the x and the a. Does that make sense? All right. So we switched it around. I'm going to move the 3 and the negative to the other side, right? So I'm going to have e to the y is going to equal negative 3x. Please ask me questions. Now, what's the opposite of e? ln. Okay? ln what equals what?
E to the
ln
negative
e to the
3x.
next,
Yeah.
There will be an invisible e there, which we don't have to write.
I have to.
And then what comes in with the place I put parentheses?
Negative 3x.
3x.
Yes.
Negative.
Equals.
Y.
Yes.
And that e would be like below the ln. Right?
That's like this ln is like log base e, but we don't have to write that much. We have abbreviation for it. It's just ln.
I was saying if I wrote the e, it'd be like down there beneath.
Yes, if you wrote it. Yes.
Okay. That one was a little easier. The A and B thing actually really helps.
Yes, having an a and b instead of x and y. That we were getting that all confused. All right, let's graph some. I want you to get in your calculator, and I want you to do y equals log x, please. Your y equal button. Y equals log x. We're going to make a table of values. Where do you find a table of values on your calculator? Second table, all right? And so when we do that, we're going to make a table of values, and then we're going to graph it. We're going to find its domain. We're going to find its range. Okay, so here's the table of values. This is the numbers I told you to pick. If we plugged a 1 in, please do that for me on your little table of values.
-1.
A -1. What happens?
Error.
You get an error. That is exactly what happens. We get an error because you cannot take logs of negatives. You cannot take logs of what? Negatives, because these are the inverse of exponentials. So if you remember when we were doing the exponents, where did we never get numbers down there? Below the x-axis, the negatives, right? Mm-hmm. So that means since these are the inverse, we can't put negatives in.
Yeah.
All right, what about 0?
Error.
Error again. What about 1? Or should it be 0.5?
Negative 0.301.
Okay, all right. Notice it's a fraction and you got a negative value. All right, that's because they're reciprocals in the exponent world, right? Mm-hmm. All right, here we go. If I put a 1 in. 0. What about 2?
0.301. Yeah.
Same as the 0.5, just the positive, correct? Well, if I put 3 in.
Got more decimals, but.
Yes. You have way more decimals probably. And then here's the next one, all right? Nothing extremely profound except when I take them and I put them on my graph. I put in my negative 0.3. So we're going to graph this, but where do we start seeing that error? We started seeing an error at what number? Do we have an error?
0.
So what if I put in, like, I want you to just check. What if it's not 0? What if it's just close to 0? Type in like 0.001. Do I get a number?
Yeah.
Okay, so it looks like that. What do we call this then? We had something that we couldn't get really close to before. We called it the asymptote. Our asymptotes before, when we were doing exponentials, were horizontal. Your asymptotes now are vertical, okay, because they're inverses. So your asymptote's going to be here on the x-axis, and so your graph is going to look like that one. It's going to come really, really close to the x-axis and come up. And depending on if we add and subtract these around, that asymptote's going to move. So for this one, what is the domain?
Greater than 0.
Okay, so I started here, I'm moving across, x is greater than 0, correct? What about my range? All real numbers. So it's going to be the opposite. When we were doing exponentials, your domain was all real numbers, and your... Because it's the inverse, it's the opposite, okay? So our domain and ranges have switched. So we got all real numbers, okay? All right, so let's do this one together. Number 31. Number 31, we have some shifting going on. I'm not going to have you worry about that shift, except this is going to help you know where your asymptote is. I would just put this in your graphing calculator as is. You're going to put your y equal, you're going to do log.
That's what I did.
Yep, that's exactly what I was hoping you would do. Put in your x plus 2, make sure you close your parentheses, plus 4.
Okay.
Look at it where it is. Do you guys can see the asymptote on your calculator? All right, so I like to draw my asymptote on, I usually do it dotted, right? We looked at our table of values and we noticed that negative 1 was positive 4, correct? And 0, when we put it into our table of values, we got 1.3. There we go. And then from there, I got asked if you kind of wing it. Well, you kind of wing it. But you know the asymptote, okay? You know the asymptote, and you know that you see by the calculator which way it goes. So you are, and you're kind of winging it, but it's just pretty accurate in the sense that we have where the asymptote is and where it's crossing.
We're winging it educatedly.
Yes. This is not like when you were doing your lines and we did the slope and the intercept. We had this perfect ruler and we had them all beautiful. These are, in a sense, more wing it in that. So our asymptote for number 32 will be negative 4. It's the opposite of that there. So I'm going to get over there and draw that. You're going to get your calculator out and just put in log, open parentheses, x plus 4. Oh, negative 3 is 0. That's beautiful. Okay. So you found that on your table of values. Negative 3 is 0. That's nice. I always like to have the y-intercept. So what is this? When I put 0 in, what do you get?
0.6.
0.6. Okay, so a little more than half there. Okay.
I just do a big dot in that way.
That's all I need. I'm going to come and I'm going to kind of wing it after that. It's not going to be super precise. I don't know how high it comes up, but
Oh, do we have to go down too? Like, can we just skip that part?
which part?
With our arrows.
You need to come down. Yes,
Okay.
you need to come down.
Why is the dot in the middle of the line?
Here, because we plugged in a 0 into our table of values.
Okay. So we type in the equation, and then we just go to second table and we plug in
And then we
zero.
put find some, and she found out when she was putting some values in that 3 was 0.
Negative 3
And I like, negative 3, excuse me, is 0. And then I always like to have where it crosses the y-axis. So we plug the 0 in for that. Okay? All right. We're not finished because we need to do the domain and the range for both of those. So number 31, the domain,
X is more than or equal to 0.
x is greater than or equal to, not equal to, excuse me, just greater than what?
0.
Well, if I come
No.
here and I have these little horizontal lines, when do I start?
Negative 2.
When do I start? Yes, at negative 2. When I start hitting it is not at negative 2, but right after it. So it's going to be greater than negative 2, right? What about the range?
All real numbers.
All real numbers. Number 32, the domain,
Negative 4. X is
greater than negative 4, and the range,
all real numbers.
all real numbers. Okay. When we were doing domain and range last time, your domain, or your range, by the way, was this number out here. And your domain was all real numbers. Now we're flipping it. It's all real numbers for the range, and it's the inside that's your asymptote, or your domain. Okay? All right, let's move on. All right, this is what we learned today. You learned what a log was. You even learned what ln was. Okay? We learned how to simplify expressions with the log and the ln. We learned how to find values on your calculator. You learned how to find inverses with both of them. You learned how to graph both of them. All right.